We are trying to solve a problem based in thermodynamics. The problem is like this. A heat engine has an efficiency of 80%. First, let me try to explain to you what's the meaning of efficiency. In any of the heat engine, we supply the heat energy. That heat energy is converted into work. So, how much of the supplied heat energy is converted into work is called as efficiency. For an ideal heat engine, all the supplied heat energy is converted into work whose efficiency is 100%, but that's not practically possible. It is given in our problem that efficiency is 80%. Right? Now, if the work done is given for you as 300 calories, so I can substitute in the place of work done 300 calories. Calories converted into joules 4.2, it becomes joules. How much is the heat energy supplied by the source? This is the heat energy supplied by the source, right? Heat from source is 80%. 80% means 80 by 100. That is equal to 0.8. That implies heat from the source is 300 into 4.2 divided by 0.8 or 300 into 42 by 8. So if you calculate this value, you will get it as 1575 joules. That's the heat energy from the source. Now he is also asking what is the heat energy rejected to the sink. If you remember the basic law of heat engine, we supply the heat from the source dq1 that do some work at the work function level, and then remaining heat energy is rejected to that of the sink. So dq2 that is of the sink is dq1 that is of the source minus work done. You know, from the source we have calculated the energy as 1575 joules. Minus it is given that the work done is 300 calories. Of course, that has to be converted into joules so that my entire answer will be in joules. So if you calculate this value, it will be 315 joule. So out of total 1575 supplied joules, from the source 315 is rejected to the top of the sink. That's how we can solve the problems basing on heat energy and heat engine, right? This is also called like a Carnot's heat engine. That's it. It's a very simple thing, and you only need to know the meaning of efficiency to solve this problem. Of course, this can be further converted into kind of temperatures. Yeah, how? I'll just write that equation for you. Work done from here can be written like dq from the source minus dq from the sink. Then I can write efficiency as using this formula dq from the source minus dq from the sink divided by heat energy supplied means dq from the sink. That can be further written like 1 minus heat energy of the sink by heat energy of the source. Denominator is source. So if you want to write it in temperatures, we can write it as temperature of the sink by temperature of the source in absolute temperatures. You can also use this formula for the efficiency when the temperatures of the source and sink is given for you. If not, we have to use this formula. This is how we have to solve the problem. Thank you for watching.